Welcome back, algebra class. We are going over elementary algebra, chapter 12, verse 2. And we're going to begin with a problem from the homework. So they give you this equation right here, y equals 3x minus 4. And I'm still continuing to excessively narrate what the numbers and the problems are, so that in case the camera goes out of focus, you can hopefully still follow. So they ask you a few things about this equation. Number one, what is its degree? So, do you remember how to find the degree of an equation? You could actually do it even without putting it in standard form, simply by asking this: what is the biggest power in the equation? And that will be its degree. In other words, or I should say this, what is the degree of the biggest, like the monomial or term that has the highest degree? So, we're not really going to need to do anything with y, but it turns out y's degree is 1, and x's degree is 1 as well. So this is a first degree equation. And before, specifically last lesson, we learned that a first degree equation has another name. That name is linear. That's going to be very important to us. Now they ask, what kind of a function is it? And it actually, that's question number 2 about this particular equation. It is a linear function. Linear equation, linear function. And then they say, what sort of a graph will it have? The answer is linear. In other words, if we were to graph this, it would be the same kind of equation that you're used to graphing from probably elementary school on. Excuse me. If you have just kind of like a little chart here, the values of x and y. Now, how many values of x and y could we have? An unlimited number. But we can just plug in whatever potential values of x and y we want. So let's say x equals, and it's good to take a smattering of negative, positive numbers and 0. So we'll start with, how about 0? We'll find our y-intercept. And this actually follows the normal formula that we would, the format for graphing, the y equals mx plus b. Format. It's the best for graphing. And I can't remember if in the graphing chapter they use some other title for it. But anyway, so y equals 3x minus 4. So if x equals 0, y equals 3, parentheses 0 as the x. 3 times 0 is 0, minus 4. And so this takes us back to the idea that the y-intercept is just going to be whatever happens when x equals 0. And it's always going to end up being just this b, this negative 4 in this case. It's going to be whatever the constant is left over. So here's our first point. 0, negative 4. Let's enter another one. How about positive 1? So if x equals positive 1, y equals 3 times 1, which is 3, minus 4, which is negative 1. So that would give us x equals 1. Y would equal negative 1. This is pretty steep, actually. All right, so now let's do 2. Let's say that x equals 2. So 3 times 2 is 6, minus 4 is 2. All right, so then and at this point, we have a pretty good idea of where this is going. It's just going to be a straight line like that. Let's do some negatives for good measure. X equals negative 1. So that'd be negative 3 minus 4 So the rise over run of this is basically, you know, we already know how to do that. 3 over 1, so that means you go up 1, 3, or up 3 over 1, or down 3, back 1. And one last for good measure. So 3 times negative 2 would be negative 6, minus 4 is negative 10. And there you have it. So this is an example of a linear equation. And the reason it's a linear equation is obviously number one, because when you graph it, it makes a straight line. It's a linear function. Function meaning it's of this form, basically y equals whatever. You plug in a value of x, and then that's going to determine what y is. And so then it's and so it graphs as a straight line. But also the other thing that allows us to immediately know just by looking at the equation that it's linear is it's a first degree equation. That's why these two names are synonymous, first degree and linear. So anytime that you have a y equals just x to the power of 1, you graph it, it'll be a straight line. You're not going to have any curves or anything weird going on. Now, what happens when we get into a quadratic equation? Quadratic meaning second degree. This one, rather than having a y equals mx plus b format for graphing it, we're going to need to set it up to have y equals mx. Here we go. I'm looking for my better black marker. These are kind of going out on me because I'm pretty much only using black markers right now, which is kind of sad. Now our form for graphing for a quadratic equation, which is going to have a power of x squared, or basically a second degree variable, y equals, and we're going to say, basically it'll be like in a form like x squared plus an x if you have it, plus your constant. And so you could say, for example, a squared plus, I should have done it like this, bx plus c. So line them up that way and that'll help. All right, let's take a sample quadratic equation and graph it and see what kind of a shape we get. All right, so we'll do a simple one. Y equals x squared plus 2x. Now we could go ahead and just for the heck of it, add a 0. I think that'll be helpful. And why is that? Well, because if you look at this, this will help us to figure out a y-intercept, which in this case will be 0. But your constant in this format, a c, whatever your constant is going to always be your y-intercept. Because if y equals a bunch of things times x, added together, plus then something that's not times x, then what happens if you make x equal 0? In other words, that point where you cross the y-axis, then the only thing left of any value is going to be whatever your constant is. In this case, there is no constant, but I put a 0 there just so we know that the y-intercept is 0. So now, time to do what we normally do, even if it's a quadratic equation, and by the way, it is because your power is 2 there, so it's a second degree equation, or you could say second degree function, and we call that quadratic. Think you're squaring it, and quad and square kind of go together. So now over here, x and y values like usual. This may seem scary because you're now dealing with x squareds, but the way we attack them is the same as we've always attacked these. All right, let's say that x equals 0. We already established y will equal 0. So I'm going to go ahead and put our starting point right there. X equals 1. Here's where things get interesting. well, I wrote -1. Let's do +1. So y equals, and then 1 squared is 1, plus 2 times 1 is 3. So if x equals 1, y equals 3. All right. Now let's say x equals 2. 2 squared is 4, plus 2 times 2 is another 4, so 4 plus 4 equals 8. What are you noticing? Does this look linear so far? Because before, when we had a linear equation, we had a rise over run, we had y equals 3x plus something, minus 4, that's what it was. And so our rise over run was up 3 over 1, then up 3 over 1, up 3 over 1. Does this look like it's going in a straight line? No, we went up 3 over 1, and then we went up 8 over 1. So it's making a curve. All right. Now let's try negatives. -1. All right. Y equals -1 squared, which is 1, plus 2 minus x, or sorry, plus 2 times -1. So 1 minus 2. So that'll give us a y of -1, and I can plot that right here. So we're kind of getting down into the dip here of this, and noticing, again, we have the curve getting steeper and steeper as our numbers grow. We'll now go to -2, see what happens there. So -2 squared, that's going to be 4. And then we're going to add 2 times -2, so that's 0. So at this point, we are actually changing directions now. You might be thinking, what on earth is going on? We need to plug in a couple more numbers to really get a clear picture of what's going on. -3. All right, so -3 squared is 9. I'm just going to actually write these out now because it's very late and I'm probably going to get too tired to do this. 2 times -3 is -6. You see, I make a point of recording when the kids are asleep, which is much later than we ever intend. Sometimes Isaac is up a lot longer than he's supposed to be, and because he's entertaining himself instead of going to sleep, and we have to catch him and then shut it all down and start certain processes over again. So 9 minus 6, so that's going to be, now take a look at this, 1, 2, 3. So we're creating a mirror image here. We have a rise and run of 1, 1, and then to the left, 1, 1. Now we have a rise of 3 and a run of 1. Now we have a rise of 3 and a run of -1. Let's see what happens if we do one more of these. Oops. All right. See if you can predict what's going to happen. Now, -4 squared is +16. And then 2 times -4, -8. So look at this. We go 1, 2, 3, 4. Wait a second. I did this wrong. 1, 2, 3, 4, 5, 6, 7, 8. I did 8 more rather than going to the 8th point. Okay, anyway. So now I got that right. Sorry about that. So back 1, and then we're going up to, that's 3, 4, 5, 6, 7, 8. So sure enough, we have, when we have a quadratic equation, what we actually create is a shape called a parabola. And a parabola is going to be a curve in one direction, but then it's going to be the same curve in the opposite direction. So it makes a mirror image. It's bilaterally symmetrical, meaning if you take the midpoint, and of course it's not going to be true in my handwriting on this chart, but if you had graph paper, if you take the midpoint, you could actually fold it in on itself and it would be exactly the same. Bilateral symmetry. Now, ask yourself this for a second, maybe even pause the video and think about it. Why would a quadratic equation be symmetrical like that? here's your answer. It turns out that if you take the square root of any number, and we discussed this last chapter, square root of 16, for example, is 4, right? But it's also negative 4. You just don't provide that answer whenever they're asking you what's the square root of 16. As a custom, we only provide the positive answers. But on a graph, you can show the 4 and the negative 4. So basically, anytime you have a negative or positive value of x and you square it, because this is a quadratic equation, so you're going to have an x squared at some point, anytime that you square x, the result is that your negative value of x and your positive value of x are going to produce the same value. So, as a result, negative 2 x squared is going to equal 4, and positive 2 x squared, positive 2 is x and then squared, is going to equal positive 4. So this parabola, by the way, would have been dead center, like just right here with the 0 there, but it shifted over because of this plus 2x. So that changes, because anytime that we, just have like negative and positive 4 as values of x, or negative and positive value, or 6 as values of x, whatever, adding a 2x to that is going to kind of shift your whole parabola over, actually 2 places to the left. Anyway, it'll always end up, if you have a quadratic equation, it'll always end up with a parabola, or an upside down parabola, which will always be bilaterally symmetrical. Now, to cover some stuff that's related to the homework doesn't really have anything that we haven't gone over. It has a couple questions where it'll just give you an equation and say, what is its degree, which will be like linear or quadratic, depending on whether the highest x value is 1, the power of 1 or the power of 2. What kind of a function is it? That's either linear or quadratic. What sort of a graph does it have? Either linear or it's going to make that parabola. They'll also have you actually graph some functions. So graph the following functions all on one pair of axes. Let one unit on the y-axis represent 5. I'm not going to do all of that right now. I'm just going to graph one more quadratic equation. And this quadratic equation is a simpler one than the last one, and I kind of wish that I had started with it. Y equals x squared. All right, first of all, if you ever feel like it, you can add a plus 0 just to help you remember that the y-intercept is going to be 0. But if x equals 0, y is going to equal 0. So we're starting right there. Say x equals 1, then y equals 1. Let's say x equals negative 1. I'm going to start doing them this way. Y will equal negative 1. No, it'll equal positive 1, sorry. And this is demonstrating that quality of quadratic equations I was mentioning, that the negatives and the positives are going to of x's are going to produce the same y's unless you have any other numbers involved. Like last time we had that plus 2x. This time we have nothing. It's just y equals x squared. So we're going to get the exact same y outcomes for negative and positive versions of x. So x equals negative 1, y equals 1. X equals 2, y is going to equal 4. X equals negative 4, y is still going to equal 4. Negative 2. Because negative 2 squared is going to be positive. 1, 2, 1, 2, 3, 4. So, yep, we have the shape of a good parabola. Let's just keep going a little bit. 3. And I'll just do it over here. Negative 3. So 3 squared is 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Parabolas, like, they get steeper and steeper. You could say they grow exponentially. That's the term for it. And the negative 3, of course, is also going to be 9, because negative 3 squared is 9. So look at this nice parabola. It goes straight through the center. and the slope starts small and grows exponentially. And again, it's bilaterally symmetrical, meaning if you folded this side in on that one, they'd be the same. Finally, the last problem with the homework, they just give you some crazy ones, which you really don't have to worry about because you just do the same thing. You just figure out a value of x and then see what the y would be. So take a look at this monstrosity. Y equals, I'm actually genuinely curious what the shape will become, x cubed plus x squared plus x. Can you already tell me what the y-intercept is going to be? Hopefully you know it's going to be 0. I'll put the graph, I'll put the chart over here. So then we just start plugging away some x and y values, see what happens. Start with 0, y will equal 0. We'll do 1. So this would be 1 cubed plus 1 squared plus 1. And what does that all equal? It's going to be 1 plus 1 plus 1, which is y equals 3. I'm saving time by not writing y each line, but I can actually do it because I'll just keep them there for all the different values. So y is going to be 3 if x is 1. All right, we'll try -1. So here it'll be necessary to put these in parentheses, like I always say to. Plus -1 squared plus -1. All right, so what's -1 cubed? Well, a negative times a negative is a positive times a negative is a negative. Negative times negative is positive, and this just stays negative. So I got -1 plus 1 minus 1. So that's going to give me y equals -1. Say x equals 2. Two cubed plus 2 squared plus 2. 2 cubed is 8 plus 4 plus 2. That'll give me 14. All right, that's going to be a little time consuming. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Need to extend my y-axis. There we go. So that's pretty steep. That's very steep. Okay. And we'll try -2. Now it does say in this problem, let one unit on each y-axis represent 10. Oh, right, okay. So in other words, this is going to get really big really fast. They want you to use increments of tenths. So I'm afraid to get any bigger than 2 for that reason, but I think maybe I'll just try -2 and then I'll try 3 just to see how big it would get. All right. So -2. So that's one thing I didn't follow the directions on, is I didn't do this in increments of 10. I've been doing increments of 1. But it says specifically on the y-axis you would do 10s. Okay. Now, -2 cubed is going to be -8 plus still 4 minus 2. -8 plus 4 is -4 minus 2. It's going to be -6. So right around there. It's interesting because when you're dealing with x cubes, it makes a kind of like if you took a parabola, which is again kind of like a wishbone shape, and just like bent it like that. I'm going to do one more for good measure. 3. Three cubed plus 3 squared. I may not graph this if it's too big of a number. It's looking like it's going to be pretty big. It's going to be 27 plus 9 plus 3. It's going to be 39. Yep, not going to do it. But let's just say, yeah, so that's 14. Then it would come somewhere up around, yeah, you can't even, somewhere up around here. Now I see why they wanted you to do increments of 10 with the y-axis. So that would have actually been 39 would just be 1, 2, 3, 4, like right there, if we were doing increments of 10. Okay, well that's going to do it for this lesson, and hope that helped. Let me know if you have any questions, comments, etc. Thank you very much.